Include the endpoints means, let's say, I want to find all the numbers between 20 and 25. List down all the numbers between 20 and 25. So if we give it like this, that is the square bracket and the close interval, we mean that the list will be like this: 20, 21, 22, so on till 25. On the other hand, if you take open interval, I'll show the difference with the same example. Open interval means, let's say I want to find all the numbers between 20 and 25, and I'm saying do this like uh, this is a round bracket says. So we exclude endpoints. Okay. So what will be the result? Uh, it will be 21, 22, and so on till 24. Here 20 and 25 is not included. Here it is included. Is the difference clear?
Yes, sir. Clear.
Okay, great. Anybody else?
I have a few more questions, sir.
Yeah, please.
Again, complement, I didn't understand, sir.
Complement. Okay. So complement is, we have to understand what for complement we need one more term, that is universe. Okay. Okay. So okay, let's take an example. I have a set X which has 5 elements: 1, 2, 3, 4, 5. Okay. For this question, for every question, if somebody is asking a complement, always ask this question back: what is the universe in which I have to find this complement? So here you have set X. My universe for this question is 1, 2, 3, 4, 5, 6. 5. Sorry, I've left 3. 3 I'll write here, and 6. Okay. So when I say find the X complement, or it's the same as this notation is also same. So it will be universe minus X, means you have to find the set difference of universe minus X, that is the given set. So your universe has 1, 2, 3, 4, 5, 6, but your current set has only 1, 2, 3, 4, 5. So when you do the set difference, you get 6. So what is the X complement? Complement of X with respect to this universe is this answer. Is this clear now or better?
Yes, sir. But for complement, this is a standard formula, which is
Yeah. There is no other way to find the complement. For now, just think it like this.
okay. So universe minus X, that's the standard.
Yes. For every wherever this complement question is there, it must have a universe. You cannot tell the answer without the universe. You can take this for sure.
Okay, so and then this the line that is drawn above X, what does that mean, sir?
Oh, that's X bar. We in notation we say X bar or X raised to power C. Both are same, complement.
Okay, sir.
There should be some notation to show complementarity, right? So this is just that.
Okay, sir. Got it.
Yeah.
This open and close interval is always with a square bracket. Is that correct, sir?
Close interval is all means, which are you referring to? This part or this part?
The open interval was square bracket. Even the close.
No, open interval is this bracket. Round bracket. Round bracket.
Okay. So I got. Okay, sir. Got it.
This is square bracket. Closed interval. By you can remember like this. O. You break this O. This is this. And closed, then just anything else is closed. So that is like this. So it is just a trick to remember it.
Got it, sir.
Anybody? You have any more questions or anybody else? Yeah.
Yes, sir. I have a question from one of the activities.
Please.
This was activity 1.3. I'm just trying
Please
to
don't
load
tell me the question number. Just show your screen. Show me the question. I don't have the questions.
Okay, sir.
Yeah.
2, 3, 4. How can I share this? Okay. Can I put it as a screenshot?
Yeah, on Telegram, right?
Yeah, because I don't know if I can.
You can share the iPad also. There is no problem in that.
Let me try. Okay, I got it. Okay, mathematics. Can you see my screen, sir?
Yes, please.
Okay. So, all right. So, question number 2. This is below is a list of real numbers. Okay. Now, in this, obviously, I made a mistake here. How many irrational numbers are there in the given list? So, for me, when I looked at it, it was square root of 3, pi, square root of 6.
Okay, but what is the answer then?
I think it was something else.
Please check. Then also I'll.
The answer was 4, sir.
Yeah, so root 3 e pi and root 6. That's all. 4. You said the same thing.
I said the same thing.
Yes.
Okay. I don't know why I chose 5.
No problem.
Okay, I'm sorry. The next was the third one. How many integers are given in the list? Now,
Okay, let's
in
start.
this case, integers is 2.5 also considered as an integer? No, right?
2.5 can be written as 25 by 10. No, this is a rational number.
This is a rational number.
49 is root 49 is an integer because root 49 is 7. That was it. Yeah, I think so. Now you will be able to solve this.
Yeah.
7, 22 minus 35, 1729 minus 20,000.
Got it. Okay. So that actually I thought as it is. So when we get a number which is like this square root of 49, we actually we reduce it to the
You
last.
first solve the whatever complexity is there, then you start counting.
Got it. Got it. Here it says which of the following statement is true. Square root of 2 is a complex number. I didn't understand this one.
Square root of minus 2 is a complex number. That's very right. Yeah. So you cannot solve under root of minus 2. There is no answer for that. Then you have to calculate I and j in terms of complexity. If it is under root 2, then it will be irrational number.
Correct.
But if it is anything under root of minus, whatever in the under root there is something minus, always a complex number. You can never solve that. At least for now, think it like this.
Okay, so basically we take that as a complex number.
Yes. But why did you is there any doubt in the second statement also?
No. Actually, I didn't understand it.
Okay.
Basically, I did not know about this complex number, and I did not get
No,
the
we
second
did
one.
it, no problem. We did it on the first day itself. So anything under root, when you do it minus of something of under root, then for now you can consider that as a complex number.
Okay, sir. And the second answer is real numbers extend rational numbers. Sir.
Yes, that's what we have discussed, right? See,
correct.
Rational numbers, that is the Q, right? Plus irrational numbers. This all becomes real numbers. That is denoted by R. So therefore, yes, this just a matter of statement. Rational numbers extend real numbers. Oh, sorry, real numbers extend rational numbers. Yeah.
Actually lost your screen for some reason. Will this? Yeah. I think I have to leave the chat. I'm not getting your screen, sir.
First one only say, sir, that options can you explain, sir? First one. Hello?
Yeah, please tell.
In that 3.1 only, the 4 options are there. So the product of two irrationals. That one only.
I cannot see anybody's screen. Let's say I'll stop sharing for some minute. Please, somebody else. Rohit, can you now please share the screen? Just give me a minute. Yeah, please.
Yes, sir.
I've closed the screen. I'll copy the question from you and then I'll show it here.
I missed your screen, sir. I didn't get it because when I was sharing.
Right now I've closed it.
Okay.
Please use share your screen.
Okay. Okay, sir. Can you see my screen?
Yeah. Let's go to that question that we were discussing, that rational numbers extend.
Which was real numbers extend.
Yes. So now you see rational numbers plus irrational numbers is basically real numbers, right?
Right.
So we are just extending. So we say that rational numbers, when it gets extended, it becomes real numbers. This statement is also fine.
Yes, sir.
I am saying that rational numbers, when it get extended, means in bracket, I'm saying that I'm adding something else to rational numbers, then it becomes real numbers.
Real numbers.
Correct.
Just reverse the statement. Real numbers extend rational numbers by something. I've added this by my own, that real numbers extend rational numbers by something. And that by something is irrational numbers.
So basically the logic is very simple. Rational and irrational together makes it real number.
Yes.
But here in this case, what we are saying is that real numbers are extended by rational numbers, which means, real numbers extend rational numbers, which means it extends rational numbers with another irrational number. That is what.
Yes.
Got it.
Any doubt? Any other doubt? Sorry.
The first one, sir. The product.
First one. Can you please keep sharing whatever that screen was?
Same page, sir. What is showing? In that only first question. In that
this one?
Options can, yes, sir.
Rohit, would you like to explain this?
The product of two irrational numbers is always an irrational. Which of the following statements are false? The sum of two natural numbers is always a natural number. Am I audible, sir?
Yeah, you're audible. Please continue.
Okay, so the sum of two natural numbers is always a natural number. This is not false. This is true. The difference between two integers is always an integer. Yes, that is also true. The product of two rational numbers is always a real number. Now, this actually contradicts what we actually just went through, sir. Is this true that product of two rational numbers is always a real number?
Actually, product of any two natural number is also a real number, right? See, it is a matter of set, right? Let me explain this. I'll share my screen for a minute, okay?
Okay.
So you can close it for 5 minutes. This will be clear once and for all. You can see the screen, right?
Yes.
Yes, great. See, the smallest set was natural, right? Natural numbers only included the 1 to something infinity. This is fine, right? This was fine, right?
Okay.
Yes, sir.
Yeah, good. When you add 0 to this, it becomes whole numbers. So your whole numbers will have 0 to infinity. This is also fine.
Okay.
So this is clearly that every natural number is whole number also, right? But every whole number is not a natural number because 0 is not a natural number. Okay. Everything is fine till here?
Yes, sir.
Okay. Good. Now, when I include negative numbers into whole numbers, it becomes integers. Therefore, integer will have everything from minus infinity to positive infinity. You have 0 also, 1, 2 also, and -1, -2 also. Great. This means integer is bigger than whole numbers and bigger than natural numbers. That is fine?
Yes, sir.
Good. Now I included fractions. Okay, I included fractions. Now when I included fractions, it becomes this integer now becomes rational numbers. So your rational number has everything 1, 2, and zeros, and minus infinity, plus infinity, but it also has fractions 2 by 5, 2 by 3, something like that. So that means now rational numbers is bigger than natural numbers, whole numbers, integers. Good?
Yes.
Okay. Now I included things like under roots. I included e, I included pi, and I included some decimal like things. Right? These things are known as irrational numbers. But when I include it in the rational numbers, it becomes real numbers. So real numbers is biggest than all of them, right? So if I say a statement is 1 plus 1, let's say I take whole numbers for now. 0 plus 2 is 2. Okay. Now 2 is a natural number. 2 is a whole number. 2 is an integer. 2 is a rational number. And finally, 2 is a real number also.
Yes, sir. Understood, sir.
Isn't it?
Yes,
Great.
understood. Yes, correct.
Now it is clear for everyone.
Clear.
Yeah. So
No,
please
but
share
that
again.
point, sir, that point which says that extending real numbers extend rational numbers, it can also mean that real numbers extend rational numbers with another rational number or with a natural number. Is that a point that can be accepted?
Yeah, exactly.
Correct.
But
Correct.
I think so that English is not very good at that place. Like kind of a mistake only because it creates confusion, no doubt. It creates confusion.
Okay, sir.
Okay,
Are
you can please.
confusions?
Yeah.
Sorry. Go ahead.
Yeah, please.
Are confusions normal in the exams, sir?
Very normal.
Okay.
Very normal. Very.
Understood.
Oh, Tejarita, did you get your answer or?
Yes, sir, I got.
Okay, great.
That
Anybody?
1.6
Any other
you will
doubt?
say today.
Yeah.
Set examples you will say, no, sir. 1.6 lecture you will say, sir, today.
Yeah. I'll start this. Once all the doubts. I hope all the doubts are clear. Should we start now with the main lecture?
At the end, can I ask regarding that set examples? I referred when I doing with active exercise. I got doubt with 2 questions.
Yeah, means we have not covered in the current lecture set, right?
Yes, that one I little forward look.
No problem. Once I have completed this part, then you can ask your doubts. Okay.
Okay, sir.
Okay, then I'll start the share screen. Okay. Maths 1. The lecture. Okay. So this is lecture 6, set examples. Okay, so now this is set. You know what is set is. You know what are finite sets, infinite sets. I'm just listing it. What are the things? Okay. Then you studied about the membership if X is the element of X or not. Okay. Then you read about subsets. Can somebody tell me what was subset? You remember?
Every X is the element of set Y.
No. This is this part. I'm asking what is this? X is a subset of Y. What does this mean?
Every element of elements in a set X belongs to elements Y.
Yes.
Set Y.
Yes. Good. Okay. Next concept was that we studied was yesterday was power set. Can you tell what was power set?
So power set is a combination of. Power set is. I don't know how to define it, but I'll try to explain it in my own words. It's a set of subsets of set. Is that what?
Yes. Great.
Right.
And we saw that for finding the formula of how many subsets can be formed from a set, we had a formula 2 raised to power n. Okay. We saw set comprehension. Uh, okay, let's do one question today. Okay. So PYQ. We have to find the PYQ. I'll not say anything. I'll just write it down. At least give me 3 elements of this set that is proper. There can be infinite elements, but give me any 3 elements of this set. Any three, because it can be anything. So try on your own. Take 2 or 5 minutes. 5 minutes is good for this. Think and tell.
both are same, sir.
HCF GCD is same. Yes. Okay. So any answers would be great now because it's about time. Anybody? Or should I start explaining?
Yes, sir.
You want to give answers?
So one I can explain, which is
Please.
P by Q, which is a rational number.
Yes, very good.
Is a subset of. Sorry, I keep forgetting the symbol.
Real element.
Element?
Not. It's not element actually. It's so that
This
symbol.
one?
Yes, sir.
This one says that collect P by Q such that P by Q belongs to rational numbers and the condition is this one.
Common factor should not be. Common factor is 1 also.
Yes, very good. Common factor should be 1 of both numerator and denominator. Okay, let's try to see this. What does this mean? Let's say I write 2y factor. Now, see, okay, what is happening? Yeah. So, let's find the factors of 2, 1 and 2. And for factors of 5, 1 and 5. This is comma. And then, so the only common factor is 1, right? So this is the correct element for this set. Okay. Acha, you tell me now, 6 by 30. Is this the correct? Is this correct or not? Can it be a set? Can be a part of this set?
Yes, sir. No, sir. No, sir.
No. Why no?
6 can be expanded into 2 into 3. 30 can be expanded into 3 into 2 into 5. There 2 and 3 are common factors.
Very good. Very good. Very good. Right. Okay. Rohit, now you please tell me, can this be a element of this set?
Is a rational number? Yes, sir. It can be. Yes.
It can. Right. Good. Why? First thing you said was right. It was a rational number.
Correct.
But what next? What more?
1 will be common in both, sir.
Let Rohit speak, please. Let Rohit speak.
7 into 1 by 2 into 5 into 1. So 1 is common in both the numerator and denominator.
No, 7, you have to see it independently, right? 7 by 10, when I write the factors of 7, it is 1 comma 7. When we write factors of 10, it is 2, 1, 2, 5 and 10.
10.
So, only common is 1, right?
1.
Common factor.
Right, Rohit?
Right, got it. Okay.
Right? So, we can include this in this. Okay, is this clear now?
So when we say highest common factor, I mean that is the only available common factor here. So that's why we consider that as a highest common factor. Is that correct?
Yeah.
If there were 2 common factors here, sir, just as an example.
Let's say, let's just take an example, 10 by 30. Okay. So your factors would be now 1, 2, 5 and 10. For 30, it will be 1, 2, 3, 5, 6, 10, 15 and 30. What are the common things? 1, 2, 5 and 10. Right. Now the count has gone to, there are 4 common factors. So this cannot. Here is 1 is the common. 1, not 1 is the common factor. Only count is 1, right?
Right.
Yeah. Okay. No doubt, we move to next question.
Also we can do now, sir.
Yes, sorry.
We can do prime factorization for numerator and denominator, and both we can pick up the common factor count also.
Yeah, that is also. You can use any other method. This is just one of the methods. Okay. Okay. I'll give you one more question. Okay. Write a set comprehension. I'll write it. Otherwise, if I speak like this, then you'll understand the answer. This is MCQ based. What is the right answer?
Only one option.
Yeah, one option is correct.
Third option.
Okay, let's see what others have to say.
Sir, third one.
Okay, great. Rohit, did you understand it?
Yes, sir. I agree. It's the third one, sir.
Okay, so everyone is clear on this, right?
Yes, sir. Do we have to write a set comprehension when such an example is given, sir?
Sorry, I didn't understand.
No, are we supposed to write set comprehensions? Like, I mean, normally, are we? Will there be such an example given where they say that you have to write a set comprehension?
No. Like, it depends. So what kind of question it is? Like here, the question was to find the set comprehension, so you have to write the set comprehension. Otherwise, it depends on the question.
Okay, sir.
Okay, any doubt here till here? Should I move in?
Yes.
Okay, so I'll move ahead now. So next lecture. Examples of set operations. Okay. So the question, I'll write the question and then I'll explain it. In a class, 30 students took physics. I'll show that as P. Okay. 25 took biology and 10 took both. Okay. 5 took neither. Now you have to find total number of students. Okay. Just create a diagram. For this question, I'll help you understand this. Then, okay. So this is the total number of students in class. 5 people have not taken either biology or physics, right? Now we have one Venn diagram for this and another for this. We have two things only, physics and biology. Okay. 10 students have taken both physics and biology, right? Till here it is clear?
Yes, sir.
Good. So 30 students took P, means physics. But out of 30 students, 10 had also taken biology. So that means only the students that took only physics were 20 in number, right?
Right.
25 took biology, out of which 10 had taken physics also. So 25 minus 10, 15 had taken only biology. Good till now?
Yes, sir.
So the total number of students will be 20 plus 10 plus 15 plus 5. 50. Is there any doubt in this?
No.
Others?
No, sir.
Okay. So I'll give you one more question, and I would expect now that you guys solve this. So this time in a class of 55 students, I'm telling you that their total number of students are 55. Okay. 32 students took physics, 11 took both physics and biology, and 7 took neither. So you have to find how many students took biology but not physics. Please solve this. Give you 5 minutes time. Please solve this.
Sir, is the answer 37?
I also don't know. I'll calculate it with you.
So the answer is 16, sir.
16.
Okay, 16. So let's calculate it. Okay. Again, I'll create this diagram because it helps easily. So once you're like very much proficient, then you don't need this diagram. But for now, let's keep it. So there are total 55 students. 7 has taken none of this. So 55 minus 7, you are left with 48, right? You are saying that only 2 subjects are there, physics and biology. Now 11 has taken physics and biology. So that means physics can be taken only by 32 minus 11, that is 21, right? Now 48 minus 21 gives you 27, minus 11 gives you 16. So 16 students took biology but didn't take physics. Good, no?
Yes, sir.
Right. The person who gave wrong answer, did you understand?
Yes, sir. I understood.
Okay, good. One more question. So this time, it's a bit difficult. Please try to, in a class of, just give me a minute. In a class of 80 students, 35 took physics, 30 took biology, and 30 took neither. So how many students how many students took physics and biology?
Fifteen, sir. 15, sir.
Very good, very good. Yes.
15, sir.
Do you want me to solve this or should we move ahead, as you say?
Can move, sir.
No, not required. Others, do you need the explanation or you have got it?
Sir,
Okay,
any example relating 3 sets, sir?
What, sorry?
3 sets. Any 3 sets were given in a combination.
3 sets example. I don't have any question with me right now, but you try to solve this. See, the concepts will remain same. So just that in 3 sets, what will happen? There will be this will be a diagram. So let's say physics, biology, and chemistry. There will be people who have taken only chemistry and not biology and physics. There will be some who took only physics, who took only biology. There will be some guys who took biology and chemistry. That will come here. Some will be physics and biology, that will come here, and physics and chemistry will come here, and there will be some guys who took all 3 of them, that will come here. So just Venn diagram will increase, that's all. Okay, you try to solve this on the basic concepts, you will be able to solve it.
But
okay, should I move ahead?
Added up now. So in that case, how minusing for how to do like that problem comes.
If you have any question with you, then I'll help you understand it.
Yes.
Okay. Yeah. So I'll move forward now. Okay. So let's try one more topic today. Okay. Okay.
Exercise is just, sir.
Yeah.
Exercise is just 1.7. In that it is.
You have doubt?
Yes, sir. Same concept.
Okay.
With little elaborate.
Okay. You want to solve it now or tomorrow?
Now can be solved, sir. Because
okay. So please,
Rohit,
Rohit, can you please share your screen if you don't mind?
Yes, sir. I can do that, please.
Yeah, please.
Because
I don't have the question.
In 1.7, in that activity, we can get first question. 1.7 activity.
Which question?
First question, sir. In a class of
just a minute, Rohit. I'll take a screenshot of this. Any other doubt? Or the only this one?
The second one also relating same only, but same even the basic of this concept only, but the question how to get understood.
Okay, I'll explain only one question. I would suggest that you solve others, okay?
Okay, first one, yes, sir, because 3 combinations.
Yeah, okay. Rohit, thanks a lot. You can stop sharing.
Okay, sir.
Okay. So please tell me that somebody can check this because the numbers are not very clear. So there are 40 total students. 20 have taken maths. How many statistics?
18.
18, no? Okay. 18 took stats.
16
16 took English.
7
took maths and statistics.
7 took maths.
7 took maths and English.
9 took statistics and English.
9 took stats and English. And 3 took all courses. Took all. Now we have to find how many students took nothing, right? Right? Is this much clear?
Yes, sir.
Okay, great. So let's form a diagram. Okay. So we have 1, 2, and 3 subjects, right? We have maths, we have stats, and we have English. Let's start with the lowest. So 3 took all, right? Good. Okay. Now let's see how many took stats and English. 9 took stats and English, right? I'm starting from this. I'm going like this. 3, we have considered 3. Now 9 have taken stats and English.
Stats and English, yes, sir.
Yes. So 9 minus 3, 6, because 6 plus 3 has already been considered. Okay. Now, how many have taken maths and English?
4.
4.
Very good. Maths and stats?
Again 4.
Very good. Now let's see. Let's consider English. So English, 16 minus 4 plus 3 plus 6. You have to do this. Because these things have already been covered, right? This thing. So what should be the answer here?
3.
Okay. I'm not calculating. I'm just trusting you guys that you are giving the right answer. Okay. How many have taken stats?
Max.
5.
I hope so. You are right. Okay. And then how many have taken maths? Oh,
7.
7. Just add them up. So 7 plus 4 plus 5 is 16. 4 plus 3 plus 6 is 13. And 3 plus 13 is 16 plus 16. So it's 32. Is the calculations right? Have we done something wrong?
Wrong.
7 plus 4 is 11.
Max 20.
32 minus 15.
Okay, so are you
40.
sure that these 20 took maths, right?
Max
18 took
9.
stats.
Max 9, sir.
Maths 9. Okay, so that was the okay. So plus 2,
English.
18.
Sorry, 9 took maths. Is that correct?
Yeah. Somebody, let me check. I'll calculate it. Okay, no problem. 20 minus, these are 4 plus 3 is 7 plus 4 is 11. 20 minus 11 is 9. Yes. So 18 plus 16 is 34. So 40 minus 34, 6 guys took nothing. Okay. Clear? Okay. So anybody else having any other doubt?
How many how many people like one fruit like that means one means what we can specify there. In the second only they asked how many people like one fruit means one means what? Is there anything we can take like a one in the second question of that?
I would suggest that you please try to solve these on the basic principles, because we have discussed many questions. If I tell you the answers for everything, it would not be good.
No, that one in three combinations we should minus the middle combinations. I do not understand.
Yes,
I do not get
yes,
so
yes.
I missed the thing.
Yes.
Okay. If 4 also come in same like middle combinations and all, we should minus off. Okay.
Okay. Any doubts, or should we do something else, or should I continue?
Continue, sir.
Okay. So next is chapter 8 is relations. For this, there is new concept called Cartesian product. Okay, Cartesian product. So we show this as A cross B. There is nothing but it's a list of A comma B. I'll explain it. Just let me write this once. A belongs to capital A and B belongs to capital B. Okay. So let's say you have one set A which has 0 comma 1, and you have another set B which is 2 comma 3. Now I ask you that please do the Cartesian product of A cross B. Okay. So what will this be? So you multiply this. So not multiply, you are just combining them. So you can think it like this. This is A, this is B. This is 0, this is 1, this is 2, this is 3. So you join it with this first, 0, 2, then it becomes 0, 3. Then you take 1, 2 and 1, 3. So your Cartesian product will be like this. A cross B is 0, comma 2, 0, comma 3, 1, comma 2 and 1, comma 3. Okay. Is this part clear? I will do more questions, but is this like a concept clear? What is Cartesian product?
Yes, sir.
Good. Okay. So you have to remember that in sets we said that the order was not important. But in Cartesian product, the order is important. 0, comma 2 is not equal to 2, comma 0. Okay. So these two are different because see, if you take the like graph paper and you take the 0, comma 2. What is 0, comma 2? Which means that x value is 0 and y value is 2. So you represent x here and y here, right? So x is 0, but your y is 2. So your x is 0, you go from here, this is 1, this is 2. So this is 0, comma 2. But if you say 2, comma 0, it means that your y-axis is now 0, and see, it lies on this. So this point is 2, comma 0. Okay, so see, these are two completely different points. These are not same. Okay. Okay. Okay.
So we basically go based on the order. So here it says A is equal to 0, comma 1. So 0
Yes.
is the first order, 1 is the second order, right? And that is how we will build the Cartesian product. Is that correct?
Yes. If I said that you find the Cartesian product of B cross A, then it will be the scenario will be different. Your B will come here 2, 3, and your A will come here 0, 1. Then it will be 2, 0 and 2, 1. This will be 3, 0 and 3, 1. So your Cartesian product B cross A will look like 2, 0, 2, 1. It will be 3, 0 and 3, right? Okay.
Yes.
Okay. Okay, so we can close here because I have to also look for the other things. I'll check the next part and then we'll continue the other. So I've given you a small brief introduction to relations, then we'll continue the other thing. Okay, so doubts are cleared. Just one more thing. Is tomorrow 5 to 6 p.m. comfortable for you guys?
It's okay for me, sir.
It's okay. Others? Is 5 to 6 okay for you?
Okay, sir.
Okay. Picharita, is 5 to 6 okay for you?
5 to 6.
Is it fine?
Okay.
Okay, so for tomorrow we'll have 5 to 6 because I have some work later. Okay.
Okay, sir.
Thank you,
We need
everyone.
to do one-to-one mapping, sir, here.
Yes, we'll just don't mix up the things. Just remember what we have studied for Cartesian product. It is not one-to-one. It's one-to-all.
Okay.
If you know one-to-one and one-to-all, then it is one-to-all, not one-to-one. Because one-to-one will be 0, 2 and 1, 3. But one-to-all is 0, 2, 0, 3, 1, 2, 1, 3. Okay. Okay, so I'll close the recording now.